Hi everyone. Today we're going to look at some features or landforms that we might expect to find on the seafloor. Please remember that most of the time we find tectonic plate boundaries on the seafloor. Very few places do these plate boundaries where two or more plates meet up and grind together. Very infrequently do we find that these cross over land. So we're going to take a look at seafloor features today. Should you need me, my email address is on the screen. I'm rcrawford@jcpsmail.org. So to begin with, when we start talking about oceans and we begin talking about ocean features, I want to just describe what an ocean basin is. And so this is a pretty good picture that shows us an ocean basin. Here we have some continental crust on one side, and on the other side we have some more thick continental crust. And in between, we have sort of this thinner crust that is oceanic crust. And notice that this is a very low place. It's a low place on the surface of the earth. And of course, that is water is going to flow down, is going to flow and sort of move downhill with gravity. So this is going to be a place where water collects. And so we call this an ocean basin. So the lowest places on Earth where we're going to have our oceans at, we call those ocean basins. Now, if we look at the very tip top of this oceanic crust down here, the surface of it, sometimes we just call that the ocean floor. So the ocean basin is these huge low places where water collects on Earth's surface, and the seafloor is just really the bottom of the sea. So when we look at seafloor features, uh, please understand that this is a very helpful diagram. All right, so I want to begin here in the middle. Much like you run into mountains and things like that on the on the continents, we're going to have some very similar features in some ways on the seafloor. All right, so let's take a look here at number one. So we can see that we have what looks like hills or like these ridges or mountains. And guys, number one, this is what we call a mid-ocean ridge. A mid-ocean ridge is a very long chain of underwater volcanic mountains. So these are volcanic mountains that are actually underwater. These are some of the longest volcanic mountains on Earth. Let's take a look at number two. So one thing that sometimes happens, and we'll take a look at this more in just a bit, is we're going to have volcanoes that they grow tall enough, they erupt enough, and have enough layers to where they stand up above the water in the sea, and these form volcanic islands. So number two shows a volcanic island. Notice that most of that island is underground, or excuse me, most of that volcano is under the level of the sea, and just a little bit is sticking up. Let's look at number three. So number three, notice, looks a lot like number two, which is a volcanic island. But please notice that this doesn't stick up out of the water. So this is what we call seamounts. So these are really extinct volcanoes that we find on the seafloor. It should be, some of you might find it quite interesting that the first three things that we looked at, the mid-ocean ridge, volcanic islands, and also seamounts, are all volcanic sort of landforms. Let's take a look at number four. So this is what most of the seafloor is like. This is something that we call the abyssal plain, and this is the deep. These are the really some deep parts of the ocean. We're looking at about 70% of the ocean floor looks like this. It is mostly flat and featureless, and it's covered by many feet of mud, and we call this the abyssal plain. Let's move over here to number five. Now, some of you have heard of these before. Number five is what we call an ocean trench. Sometimes they're called a deep sea trench. And what these are these really long, narrow, and extremely deep canyon-like features that we find on the seafloor. As we look at six, please notice that we have this on either side. Here we can see the place where we begin to get into the continental crust. All of this stuff in here, this is all oceanic crust. These are all oceanic landforms. But now we're to the what we call the continental margin, and this is the continental slope. And we know that continental crust is a lot thicker than that oceanic crust, so we usually have a pretty steep slope that leads us up to the edge of a continent. And then we have this bit right here, which we call a continental shelf. The continental shelf is really just part of the continent that is submerged or covered by some shallow water. Now, I want you to imagine that if the sea levels were to drop, this would become new land, right? So if we were to, for some reason, have the level of the water in the ocean drop, this would become part of the continent, okay? So we have the mid-ocean ridge at number one. We have a volcanic island at number two. These are called seamounts, which are extinct volcanoes. These are these flat, featureless plains called the abyssal plain. Here we have a deep sea trench, which are these very deep canyon-like features. Here we have a continental slope, and over here we have the continental shelf. All of these are part of the continent and are of continental crust. When we start thinking about ocean basins, I think it is a little lost on us exactly how deep the oceans are. So, when we look at the seafloor, the seafloor on average down to the abyssal plains have about 2.5 miles of water on top of them. Guys, 2.5 miles, that's something like 11,000 feet of water that is covering up these abyssal plains. Now, as we move deeper and deeper, sunlight can really only penetrate the first few hundred feet. As we move down below a few hundred feet, I want you to know that it is completely dark. It would be just as dark as it is at night here on the land. And so, you're talking about really dark places out in the deep sea. The truth is, large parts of the ocean are completely unexplored, and some of them are a little bit inaccessible for us. They're hard to explore. We probably know more about the surface of the moon than we know about the seafloor itself, which is really kind of crazy considering that that's part of our own planet. So I want to look a little bit more at really three features. The first feature I want to look at is that mid-ocean ridge. Remember, I said that the mid-ocean ridge is just a long chain of underwater volcanic mountains. And so if we look in this picture, we can see where we have these very long chains, and these are all really connected together. This is going to be our mid-ocean ridge. Everywhere where we can see sort of out in the middle of the ocean, these mountains. I do want to tell you that this is the longest mountain chain on the entire Earth. It is something like 40 because it's all chained together. Like this over here would meet up with this. It's something like 40,000 miles long, which is really quite incredible. And these are not really small mountains either. So many of these mountains are roughly 3,000 feet tall, I think on average, which is about the same elevation as the mountains that we live in here in Jackson County. Now, a mid-ocean ridge, we said that they're volcanic mountains, but the really crazy thing is we're really looking at really a fissure eruption, right? So essentially we have like a big crack that goes on along the ocean floor that we're going to have magma that is going to rise to the surface along these. And this magma is going to rise, this crack is going to come in what we call the Rift Valley. And the Rift Valley is just a V-shaped valley that's at the very center of this mid-ocean ridge. Just understand that the lava, the lava is sort of erupting onto the seafloor. So as you can imagine, it's going to cool very, very quickly here. When we look at the mid-ocean ridges, I want you to please notice everywhere that I have highlighted in pink, this is where those mid-ocean ridges are. And please notice that they exactly follow those plate boundaries. Now, not all plate boundaries, as we can see, have a mid-ocean ridge at them, but we can see that many plate boundaries, tectonic plate boundaries, have a mid-ocean ridge. Let's also take a quick look at these ocean trenches. These are, guys, the deepest parts of the ocean. Some of you maybe even have heard of the Mariana Trench. The Mariana Trench is almost 7 miles deep, which is really the deepest place in the ocean. There is a particular part called Challenger Deep, and we have been able to take a few submersible vehicles to attempt to explore it. But the oceans really are deeper than Mount Everest is tall. These deep ocean trenches are the deepest places on Earth. If we look at these ocean trenches, please notice that not in the same place that we found those mid-ocean ridges, but notice that these deep ocean trenches also follow the edges of tectonic plates. Anywhere I have this pink highlighting, over top of that plate boundary, that means that we're going to find one of these ocean trenches, one of these deep sea trenches there. All right, and let's take a look now at volcanoes, undersea volcanoes. So to begin with, any volcano that erupts under the sea, we call a submarine volcano. So an active volcano that erupts underwater is called a submarine volcano. So let's take a look sort of here at this progression at what's happened over time. So if we look here at number one is showing lava pouring out of a vent. Now we know that as lava pours out of a vent, sometimes it's going to build up. It's going to build up a cone. All this as the lava comes out of the vent, it's going to cool and harden into rock, and over time, it's going to make sort of this cone-shaped mountain. And so we start with a vent, and we're going to move to an underwater, a submarine volcano. If this volcano keeps erupting, it will eventually erupt enough and get tall enough to where it is going to stick up out of the ocean. Guys, that's how volcanic islands are formed. They often start out deep under the surface of the ocean, and after they erupt and grown and built layer upon layer, you will end up with a volcanic island. When we talk about volcanic islands, it's important to me that you know that we're not talking about small structures. Really, Mauna Kea, which is it's part of one of the islands of Hawaii. I want you to notice that its total height off of the seafloor is over 33,000 feet. When we talk about the tallest mountains on Earth, we really talk about something called Mount Everest, which is part of the Himalayan mountains. Notice, though, that from the top of the crust, the Mount Everest is only about 29,000 feet tall. So truly, a very good argument could be made that some of these volcanic islands and some of these sort of volcanoes that rise up off the seafloor are really the tallest mountains on Earth. Volcanic mountains or volcanic islands do not always form alone. Oftentimes, you're going to find that they're going to form in chains where you will have sort of several volcanoes and volcanic islands or submarine volcanoes and volcanic islands all in a row. There are lots of examples of this, which we're going to look at. Japan, the Aleutian Islands, the Philippines, Indonesians. I do want to point out that we can have these volcanic arcs form on continents, but we are really just worried about these islands for now. Where do we find these volcanic islands and arcs? Well, we find them at plate boundaries. Guys, that's really going to do it for today. I hope you have a great day, and we'll talk again soon.